the last thing we want to talk about with this implicit differentiation section is higher order derivatives. So here we have 2x cubed minus 3y squared equals 8, and we want to find the second derivative with respect to x. And again, I care what it's with respect to. So that means if it's not an x, if I have a variable not x, I need chain rule on it. So to find the second derivative, I first need the first derivative. So derivative of 2x cubed is 6x squared. Derivative of 3y squared is 6y. But then I need the chain rule, so times dy dx. And derivative of 8 is 0. I'm going to go ahead and isolate my dy dx. So I get that dy dx equals x squared over y. Now, I need to take the derivative of this. So when I take the derivative of the first derivative, that is the second derivative. It's actually the definition of it. Then to find the derivative of x squared over y, I need to use quotient rule. So bottom times derivative of top. Oops. Clean that up a little bit. So derivative of the top would be 2x. Because it's with respect to x, I don't need the chain rule there. Minus the top times derivative bottom, which would be 1, but I need the chain rule, so times dy dx, all over the bottom squared. So now I can clean this up a little bit. The big thing to note, though, is that this dy dx here, we actually already know what dy dx is, so in this case, I can go ahead and actually plug in what we found for dy dx. So we get that the second derivative with respect to x is going to equal 2xy minus x squared times x squared over y over y squared. And then if this were multiple choice, this would get simplified sum. We would get the common denominator and turn our whole numerator into one fraction and then divide that by y squared, which if we did that would give me 2xy squared minus x to the fourth all over y cubed.